Hey everyone! Today in Integrated Science, we're going to start section 3. This section talks about measurement, which is pretty important in science. I've divided this section into 3 parts because it does introduce and deal with some math. Not everybody is great at math, so I want to take it a little bit slower for those who might be struggling. And with that being said, if you are struggling on any part of these videos, please make sure that you just contact me and we can work through these as needed. So let's start part 1. It begins by asking questions. How old are you? How tall are you? When you answer these questions, you're giving measurements, such as, I'm 16 years old or 5'4". Measurements are important in both science and everyday life, and in fact, it'd be difficult to do science without any kind of measurements, such as taking the mass of something, the volume, density, and even right here in the picture, they're taking the temperature of something. So we're going to begin learning about scientific notation. It is my understanding that you guys have learned this in junior high, but this is going to be just a reintroduction and a touch up on it. If you are struggling with it, please make sure you ask. Our key question that we want to answer in this section is, why is scientific notation useful? Or in other words, why is it a useful tool? Well, the reason it's so useful is because scientists work with very large numbers or very, very small numbers. And this allows them to work with these very big and very small numbers more easily. For example, astronomers can estimate that there are 200 billion stars in our galaxy. And instead of writing this number every single time they want to write 200 billion, they can write it in scientific notation and give a little bit more meaning behind it. With that being said, we can define scientific notation as a way of expressing the value as the product of a number between 1 and 10 and a power of 10. Oftentimes, scientific notation looks like one or the following. Note it says a product. So when we see product, we see multiplication here. So this is our product. This right here is our number between 1 and 10. So it's to be greater than 1 or less than 10. And then here, this is multiplying to our power of 10. So this number right here is sometimes called an exponent. Now you can note in this example, the exponent is positive, but over here you can see the exponent also can be negative as well. So when writing things in scientific notation, we're going to talk about what does it mean when you have a positive exponent, and then what does it mean when you have a negative. So let's start with the positive first. For any number that is greater than 1, so that number can be 984, it can be 12, it can be 1000. Anything that's bigger than 1, we write scientific notation with a positive exponent. So a good example of this is the speed of light. Here is the number for our speed of light. It is 300 million meters per second. And we can rewrite that into scientific notation of 3.0 times 10 to the 8th. But how did they get this scientific notation from this number? Well, the easy thing is, let me rewrite it, is first you need to figure out where your decimal is located. If you do not see your decimal here, assume that it is at the end of the number. Well, we want this number in front of it to be between 1 and 10, and it's not. So you want to make sure you keep moving that decimal over until there is one non-zero digit in front of it. So here's my 3, it's not a 0, and it's the only one in front of it. So that's where I'm going to put my new decimal, 3 point. And you can put 3.0 or you can put 3 times 10. Now the reason they got this 8 is because they moved it over 8 times. And it's positive because this number was bigger than 1, but also because we moved our decimal to the left. For numbers less than 1, These are going to be written in scientific notation with the exponent being negative. So example of numbers less than 1 could be 0.67, 0.00008, or 0.000000079. Any of those are possible examples. Here's an example the book gives you. An average snail's pace is 0.00086 meters per second. And they can take this number and turn it into 8.6 times 10 to the negative 4. All they did was, here's my decimal, they moved it over 1, 2, 3, 4. Now they put the decimal here because 8 is my non-zero digit to the left of it, and it makes this number be between 1 and 10. Then I can put times 10, and I moved my decimal if I counted 1, 2, 3, 4 times. And so that is why I'm able to say to the fourth, and it's negative because this number is less than 1, but also because you moved your decimal to the right. All this negative exponent tells you is that that's how many decimal places are going to be to the left of 8.6. So here in standard form, this is what I always tell people. To change from standard form to scientific notation, make sure you move the decimal where there's one non-zero digit to the left of it. Count how many decimal places that you moved, and this is going to be the exponent on the 10. Again, if the number was less than 1, it's a negative exponent, but if it is bigger than 1, this is going to be a positive exponent. So right here, I gave examples in class, and I would like you guys to pause the video and attempt these, and then we're going to go through the answers next. So just make sure you pause it. Okay, hopefully you guys paused the video and worked through these. Let's go through the answers. Well, here on number 1, you don't really see a decimal, so it's going to be assumed to be at the end. And I have to move my decimal 1, 2, 3, 4 to the left. And I need to move it right here so that when I rewrite my decimal right there, this number is between 1 and 10. Also, there's one non-zero digit to the left. Then I can say times 10, and I moved it 4 times. And then it stays positive because this number is bigger than 1. When I look at the second number, here you should move it 1, 2, 3 spots to the right, 3.872. Note that there's only one non-zero to the left of it, that's that 3, times 10 to the negative 3. Now the reason it's negative is because this number is less than 1, but also you can see your arrow moving to the right. On number 3, hopefully you note that the decimal goes at the end because it's not seen. So 1, 2, 3, 4, 5, 6. 3 times 10 to the 6th. It's going to stay positive because this number is bigger than 1. Here with my 2, my decimal is right behind it. I don't need to move that decimal, so it usually just stays 2 times 10. Since I didn't move it, 10 to the 0. And last one, here's my decimal, and I need to move it to the right just one time because I need one non-zero digit in front of it. So 4.78260 times 10, since I'm moving it to the right, and this number is less than 1, to the negative first. So how did you guys do? Now, putting things in scientific notation is awesome, but I feel like you should also know how to take it out of scientific notation and put it in standard form. So what you need to simply do is move the decimal point to the right if you have a positive exponent. In other words, you want your number to get bigger, and you move your decimal point to the left for any negative exponent because you want your number to get smaller. If you move your decimal point and there's any blank spots, use zeros to fill these in. So here we have examples of different scientific notation, and we're going to move them to standard notation. So first and foremost, this number right here tells us how many times we're going to move the decimal. The sign tells me if I'm going to move it right or left. So if you see a negative, that means that I'm going to move it to the left. If you see a positive, that means you're going to move it to the right. So here I have a negative and 5. So I need to move this decimal 1, 2, 3, 4, 5 to the left. And then notice here I have these blanks. This is what I'll fill in for zeros. So this becomes 0.000047. Here on this example, note that this tells me I'm moving it 6 times. Since it's positive, I'm going to move it to the right 6 times. So here I have 1, 2, 3, 4, 5, 6. Fill these in with zeros. Note when you rewrite the new number, the decimal has changed places, so please don't write it in the old place. Okay, there you go. And I want you to kind of pause this video and try the other 3, and then unpause it when you get a chance to try them. Okay, hopefully you guys tried the other 3, so let's go ahead and check your answers. Here, this one says I'm moving this to the left 2 times, 1, 2. So you should get 0.01114. Here, on number 4, it says I'm moving 1, and positive means to the right, making this number bigger. Positive means bigger. And then over here for the 9, it says I'm going to move this 9 spots to the right because I want my number to get bigger. 1, 2, 3, 4, 5, 6, 7, 8, 9. And when you guys go to rewrite this, 6, 6, 6, 7, 8, 1, 2, 3, 4, 5, 6. How'd you guys do? And with that said, the last thing we have to cover is multiplying and dividing in scientific notation. To multiply numbers written in scientific notation, we have to multiply the number that comes before and then add our exponents. So for example, here are 2 numbers that we're trying to multiply, 3.0 times 10 to the 8th and 5.0 times 10 to the 2nd. What we're going to do is we're going to multiply these numbers out front. So 3 times 5 gives me 15. But then it says add the exponents. So 8 plus 2 gives me my 10. Because this is not incorrect scientific notation, because 15 is not between 1 and 10, if you take the decimal and move it to the left, this actually adds 1. So I can take 1.5 times 10 to the 11th. This is actually about the distance between the sun and Earth. When dividing, it's a little bit different. We're going to divide those numbers in front, and then what we're going to do is subtract your exponents. So here's an example of the 2 that are being divided. Again, we divide our first number, so 1.5 divided by 30. That's how they got the 0.5. Exponents we're going to subtract, so 11 minus 8, that is how you got the positive 3. Now, this number is not in correct scientific notation because it's not between 1 and 10. So what we did was we took the decimal and moved it to the right. Since we moved to the right, that's going to subtract 1. So that's how I get the 2 over here. 5.0 times 10 to the 2nd. What I want you guys to do now is kind of pause this video and try to solve for it and see how you do. And then you guys can unpause it and go to the next slide to see the answer. Here it says a rectangle parking lot has a length of 1.1 times 10 to the 3rd meters and the width of 2.4 times 10 to the 3rd meters. And I want to know what is the area of the parking lot. Well, 1, I would know that area equals length times width. So I'm going to be multiplying my length, to my width and checking this. Notice here you're going to see multiplication. So what we're going to do is we need to multiply the numbers out front. When you see these numbers, we have to say 1.1 times 2.4. And you should get 2.64. Now this always has a times 10, so I got to figure out what that number is. 3 plus 3 gives me 6. And then of course meters squared. That's the end of today's lesson. If you have any questions, please make sure you ask. And otherwise that, I hope you guys have a great day.